Section 6.3, okay, areas under any normal curve. So what do we do if we have just a normal curve and we want to find probabilities? Well, we're going to standardize it. We're going to take the x, change it into a z, and then we can use our z table. So let's look at some examples. The length of time to complete a door assembly on an automobile factory assembly line is normally distributed with mean mu equals 6.7 minutes and standard deviation sigma equals 2.2 minutes. For a door selected at random, what is the probability that the assembly line time will be 5 minutes or less? So we want the probability that x is less than or equal to 5. So our first job is, we can't find the probability of an x. I don't have a table for this particular distribution, so we're going to change this into a z. So I'm going to keep my probability statement. And I'm going to say the probability that z is less than or equal to, now remember, we use that x minus mu over sigma. So x is 5 minus mu, which is 6.7, over sigma, which is 2.2. So this is the probability that z is less than or equal to negative 0. It goes 772, so 77. Less than is an area to the left. This is a z. I'm now ready to go to my z table. I'm going to come over here to negative 0.77, and I get 0.2206. 0.2206 is my answer. Okay. All right. We want the probability of at least 7 minutes. Well, that means 7 minutes or more. So this is the probability that x is greater than or equal to 7. So the probability that z is greater than or equal to, and we do our x minus mu over sigma. So 7 minus 6.7 over 2.2. So this is the probability that z is greater than or equal to, I get 0.136. So this is 0.14. Now this is a greater than, right? That's an area to the right. When I look up 0.14, it's going to give me the area to the left. So I have to do 1 minus that area to the left. So 0.14, 0.5557. So I get 0.4443 as my answer. Okay. And then, of course, we've got a between 6 and 9 minutes. So we want the probability that 6 is less than or equal to x is less than or equal to 9. So we're going to change these into z's. This is the probability. X minus mu over sigma. So 6 minus 6.7 over 2.2 is less than or equal to z is less than or equal to 9 minus 6.7 over 2.2. Okay, so let's work these out. 6 minus 6.7 divided by 2.2, I get negative 0. It goes 318, so 32 is less than or equal to z is less than or equal to, and then 9 minus 6.7, all divided by 2.2, it goes 1.045, so 1.05. All right, remember on the betweens, now whatever, on the betweens, it's this big area minus the small area to the left. So I'm going to look up 1.05. 1.05 is 0.8531. Minus, and then I'm going to look up the negative 0.32. Negative 0.32 is 0.3745. So 0.8531 minus 0.3745, and we get 0.4786. Okay. Okay. Okay, inverse. All right, inverse normal distribution. We're going to use our table a little bit backwards. Now we don't know Z. We're going to find Z such that 35% of the area under the standard normal curve lies to the left of Z. So basically, I've got some value. If I'm right in the middle, I have 50% to the left. So I know I'm over here a little bit. You know, I know this is my 0, 50%. I'm over here somewhere. I know I'm on my negative Z side. I just don't know what it is. And 35% of the area is to the left. So this is an area to the left. So I need to go to my Z table, where my negatives are, and look in at the areas and try to get as close to 0.35 as possible. Now, as I'm looking through here, I see a 0.3483 and a 0.3520. This one's 20 above 0.35. This one's 17 below. So this one's a little closer. So this is what I use. So I'm going to look across. This is at negative 0.39. So Z equals negative 0.39. Find Z such that 5% of the area under the standard normal curve lies to the right of Z. So again, I'm right here, 0's in the middle, 50%'s to the right. If I only want 5% to the right, then I've got to be way up here somewhere at a positive Z. Now my table gives us area to the left. So if I want the Z that's got 5% to the right, it's the same as the Z that's got 95% to the left. So I'm going to go to my positive Z side, and I'm going to get as close as I can to 0.95. And if you look around in here, there's a 0.9495 and a 0.9505. Now this one's exactly in the middle. So I'm at 1.64, and I'm exactly in the middle of 0.04 and 0.05. So I'm going to write that as 1.645. All right. I'm going to stop right here, and we will have a part 2.